Welcome to another tutorial of ProfLearn YouTube channel. In this video, we are going to look at IGCSE Physics, the topic of sound waves. We are going to see different areas you must know as you are preparing for your IGCSE exam. If you are taking Cambridge Physics, this is a lesson for you so that we can be able to see how do you approach different concepts. What do you need to know as far as IGCSE Physics sound is concerned? So we shall start by looking at what is sound. Sound is a type of wave, and in this case we are going to say is a longitudinal wave because particles vibrate parallel to the direction of the wave. So sound is produced by vibrations, and when particles vibrate they move back and forth, and in that way you're going to realize there's a region where the particles are spaced and there's a region where the particles are closely packed together. Region where the particles are spaced, this region here, it's called refraction. Region where the particles are quite compact, closely packed, we call that compression. So when sound is produced, it's going to be transmitted through a medium. So if an object vibrates, those sound waves are going to travel through air, they enter into your ear, then that sound is going to cause, that wave is going to cause your eardrum to vibrate, and then you can be able to hear the sound. Now what you need to understand here is that sound is produced by vibrating objects, and different examples of vibrating objects could be guitar, could be a tuning fork, could be a drum. When the skin of a drum vibrates, then sound is going to be produced. So if you're going to be asked sources of sound, look at those objects which are vibrating, and those are going to be the sources of sound. As I'm speaking right now, my vocal cords are vibrating, and then in that way sound is produced, which is transmitted through air into the microphone so that you can be able to hear me on the other end. You need to understand that compressions are regions of high pressure and rarefactions are regions of low pressure. So this region where you have the lines closely packed, that is what we call the compression. Where the lines are spaced like that, that's going to represent a rarefaction. So if you are asked to find the wavelength of a sound wave, what you're going to do here is to identify the center of a compression and the center of the next compression. Then you measure that distance, that's going to give you the wavelength. There's something also you need to understand that's called the human hearing range. A human being can only detect sound which have frequency between 20 Hertz to 20,000 Hertz. So if an object is producing a sound which is between 20 to 20,000, a human here can be able to depict that sound. A person can be able to hear that sound being produced. But if sound produced is less than 20 Hertz, for instance, let's say a sound is produced of frequency 15 Hertz. That sound you cannot be able to hear because that is outside the human hearing range. If a sound is produced which is above 20,000, let's talk of 2 megahertz, that is more than 20,000 Hertz, then that sound you cannot be able to hear it because it's not between 20 and 20,000 Hertz. So anytime you are asked to identify that human hearing range, you need to understand is between 20 Hertz to 20,000 Hertz. A sound that has a frequency less than 20 Hertz is called infrasound. Infrasound or infrasonic sound. Infrasounds are sound that have frequency below 20 Hertz. So as a human being, you cannot be able to hear infrasounds because they are sounds below the 20 Hertz. Ultrasounds are sound above 20,000. Okay? So if a sound is above 20,000 hertz, that type of sound is known as ultrasound or ultrasonic sounds. Sound that is below 20 hertz is called infrasound. Sound that is above 20,000 hertz is called ultrasound. So animals like elephants, they can detect sound which is below 20,000 hertz. Human being can only hear sound between 20 and 20,000, but they can detect sound above ultrasound. By the way, bats are blind, they cannot see, but they use sound, ultrasound. They use sounds for them to determine the distance between the obstacle. They send a sound. Once it's reflected to them, they can be able to gauge what's the distance so that they can be able to avoid that obstacle. So you need to understand that as you are aging, or as you age, the human hearing range also is affected because the sensory cells in the ear deteriorate with age. That's why you find old parents, old grandparents, they are not able to hear they strain to hear compared when you are young. Right, so remember we have mentioned that sound is as a result of vibrations. So those are key areas that you need to put into consideration. Regions where the particles are closely packed, that's the region of high pressure, and that is called compression. Region of high pressure where the particles are closely packed. In this region, particles are move very fast. The distance between them is very small. They are having high pressure. But rarefaction is a region of low pressure. Particles are far apart and they have a low pressure. You need also to understand that sound is transmitted through media, and different media transmit sound at different speed. Sound travels fastest in solids, followed by liquids, followed by gas. In your exam, you need to be able to give approximate speed of sound in solid. You will say around 5,000. If you are asked to give an approximation of speed of sound in water or a liquid, you are going to say it's 1,500. If you are going to be asked in an exam to give an approximation of speed of sound in air, you can say for 330, yeah, 330, 340, because speed of sound in air is ranging around 300 and something, yeah, meters per second. And the reason as to why sound travel fastest in solids is because particles are closely packed, and this enables the vibration to transfer faster, right? And that is what you ought to know, that area. You need to understand that sound usually travels at a lower speed than light. Sometimes during a thunderstorm, you could see light, then you hear the sound, because sound travel faster than light travel faster than sound. You need also, we have mentioned that sound require a medium for transmission. There must be medium, either air, solid, liquid. Then if there's nothing, then we say in a vacuum, sound cannot be transmitted. Another area that you need to understand is determination of describing an experiment on how to find sound. As an IGCSE student, you need to know how to describe an experiment. Experiment to determine sound in air. And in this case, we can be able to say direct method. Now, in this case, we're having two friends. These two guys are standing 100 meters apart. This gentleman is going to produce a sound and the lady here is going to start a stopwatch the moment it sees the object which are banged together come together. So the immediately sees the object touching will start a stopwatch, and stop it immediately she hears the sound. And then they can be able to repeat this and find the average. So we can say, use a tape measure to mark a distance between two people in a quiet open area. Two people to stand some distance apart. And in this case, the distance we can use approximately should be 100. Around 100 in this case. One person to create a loud visual signal by banging maybe wood together, and the other person to start the stopwatch when he sees the sound being produced, and stops when he hears the sound. This can be repeated around 3 times so that they can be able to find the average time, and then to find the speed, use the formula distance between, now in this case 100 over the average time taken to hear the sound. So anytime you are asked to describe an experiment on how to determine the speed of sound, you are going to illustrate exactly what have I outlined here. Okay. Number 2, we are going also to look at another method. There is another method you can be able to use, and this method is called echo method. You need to understand that an echo is a reflected sound. When sound travels from one point to the wall and comes back, that type of sound you hear after the reflection is called an echo. And something that you need to understand, guys, here is that an echo covers twice the distance, because sound is going to travel from where it's produced to the wall, and it's going to be reflected back. So if the distance is 50 meters, it will cover 50 meters, and then it will come back. And then it will come back 50 meters. So the total distance, Karugai, it covers a distance of 100 meters. Now, in this case, you can see 50 and 50 is going to form 100 that we used in the previous section. So whenever you are describing echo method, a person or two people are going to stand 15 meters in front of a large wall, produce a sound, time how long it takes from when the sound is produced to when it hits the wall, comes back for them to hear. Is that clear? Respond. Is that clear? All right. So which means that the steps you are going to write: number 1, use a tape measure to mark a distance 50 meters between a person and a large hard wall in a quiet place. A person claps 2 blocks and immediately starts a stopwatch, stopping it upon hearing the echo. You will start a stopwatch. Immediately the sound is produced. You listen. Once you hear the echo, you stop the stopwatch again. So you are timing how long sound is going to travel from where you are to the wall and back. Repeat this process 3 times and calculate the average time of echo return. So to calculate now the speed, 2 times the distance from the wall, divide the average time taken. Why do you think we are using 2 times the distance? Who can answer that question? Just write in the comment section below. Why 2 times? We are saying 2 times the distance because of this reason. Because of this reason. Just a minute. I just want to change something for you here. Yeah, so I needed to ensure that those bullet points are clear for you so that you can be able to see what we are having. The previous section, we highlighted the steps you are going to use for you to find speed of sound. Direct method, 2 people to stand how many meters apart? 100 meters apart. One person start a stopwatch, immediately he sees the woods hitting together and stop the stopwatch. This person will start the stopwatch, immediately he see these 2 pieces hit together. Immediately she hears the sound, she will stop the stopwatch. Then she is going to repeat this 3 times and then find the average time. Then to find now the speed of sound, total the distance between which is 100 divided by the time taken. Method 2, echo method. 50 meters from the wall, produce sound, time how long that sound, the echo will be heard. Then repeat that and then use the formula 2 times distance. We are saying 2 because sound will travel to the wall and come back. So you will hear the sound after it has traveled to the wall, has returned back to you. So it has covered the distance of 50 meters twice. That's why we have to say 2 times the distance from the wall. The next area, you need to understand that sound is also a wave, because we have said sound is a longitudinal wave. And if sound is a longitudinal wave, just like another wave, it's going to obey the wave equation. Remember, the wave equation is speed is equal to frequency times wavelength. This formula that we are having at this given point. Speed of a wave is equal to the frequency of that wave times the wavelength. Now, you have to ensure that your frequency is in hertz. If your frequency is not in hertz, for instance, is in kilohertz, you have to change that by multiplying by 1000. Don't fail because of forgetting that K in physics means 1000. Capital M means 1 million. Okay? Then we have a question here. A sound wave has a frequency of 250 hertz and a wavelength of 136 centimeters. You cannot use these centimeters the way it is. You have to convert the units of wavelength, or the distance between the compression, which is representing the wavelength, in meters. All right? So we have to convert 136, divide this by 100, it will be in meters, 1.36. Then now we can be able to say speed is equal to frequency, which is 250 times 1.36, which is going to give us 340 meters per second. So you can see here the value we are having for speed is 340, which is indicating that this is speed of sound in which medium? In which medium? Yes, air. Now, a source in water produces sound wave with a frequency of 6.0 kilohertz. So if it's 6.0 kilohertz, you have to convert this to hertz. You multiply 6.0 by 1000, that is going to become 6000. Then now you can now proceed to work out the frequency, the speed, because speed is equal to frequency times wavelength, and that is going to be 6000 times the wavelength. You can see it well seated here, which is 0.25, and if you work it out, you're going to get 1500 meters. This is speed of sound in air is around 340, but speed of sound in water is around 1500. These approximations in IGCSE, you have to know them. In solids, it's 5000 meters per second. The next area that I want you to be able to understand is the concept of the effect of amplitude and frequency. Amplitude and frequency. What does the value of amplitude affect? What does the value of frequency affect? You can see this wave that we are having here. It has a small amplitude. This one has a larger amplitude. If a sound has a higher amplitude or a bigger amplitude, it means that's a loud sound, meaning that it has high energy, so it will make your ear to vibrate faster. But if a sound has a low amplitude, it's going to be a quiet sound or a faint sound. So loudness is determined by the amplitude. So we can be able to say loudness is subjective perception of sound pressure. Is a property that determines whether the sound perceived is loud or faint or quiet. So sound waves, if you want to know how loud a sound is, you look at the amplitude. If the amplitude is big, that is a loud sound. But if we are talking about the pitch of sound, you look at the frequency. If a sound is making more turns per second, it means it has a higher frequency, and that type of sound is said to be having a high pitch. Look at a whistle. A whistle produces sound of high pitch. But a drum produces a sound of a low frequency, which has a low pitch. So if you are asked to draw a sound of a high pitch on this same graph, you are going to draw a wave which is making a lot of turns. Okay? If you are told to draw a wave which is loud than this one, you are going to draw a sound which has a bigger amplitude. Loud sound have loud sound have bigger amplitude. Quiet sound have smaller amplitude. High-pitched sound, like the sound produced by a whistle, has a high frequency. A low-pitched sound, like a drum, produces a low-pitched sound. In this case, we are going to have different worked examples that you really ought to know how to work out. Maybe you can be able to see here. Hakuna calculator. So if you are having a person making some sound, this sound will travel to the obstacle and then it's going to come back. So a child yells at a canyon and hear the echo after 1.8 seconds rather. How far away is the canyon wall from the child? Assume the speed of sound in air is 343. We have said that speed of sound is equals to distance over time taken. So in order to work out this, we are going to calculate the total distance. The total distance is going to be what? The total distance here is going to be, is what we are finding, isn't it? So we are going to say now distance is equal to speed times time. Distance is speed times time. Then we shall now work out that by saying 343 times 1.8, which is going to give us 617.4. But what you need to remember is sound will travel, this time we are having here is the time taken for sound to travel from this point to that point until back. So twice the distance. So meaning the value you have gotten here, now we have to divide by 2 to get 308.7 is the distance between this boy and the rock. The question we need to ask ourselves is, why was the child yelling? But the distance, we have gotten it. We have not been told why the child was yelling at a rock. All right, so the rest of the part is the applications of sound, especially for sonar. Sound is produced, ultrasounds are produced by the ship, and sound travels to the wall or the bed of the ocean, and that sound is reflected back so that they could be able to determine how deep the ocean is. Remember, if we know the speed of sound in water and the time taken for the pulse to be produced until it's received back, we can be able to apply the formula and get the distance or the depth. We can also take some time, work out these questions that we're having here, and the solution is there. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. See you in the next tutorial.